So before we move on to solving equations, there's another kind of class of question or expression we need to look at, and that's this one here, where we have a mixture of trig functions. For example, the cosine and the inverse sine. Then also when we get to the end, we're going to briefly talk about the inverse functions of the other three trig functions. So how do we do this? Well, when it's a number like the square root of 3 over 2, I know what that is. I know that the inverse sine of the square root of 3 over 2 is pi over 3. So this is the cosine of pi over 3, which is 1/2. Okay, simple enough. Now, take a look. Try this one. Remember, you got to be mindful of the domain, of the range of that inverse cosine function when you're doing this. All right, inverse cosine negative square root of 3 over 2. It's negative, so I need a second quadrant angle whose cosine is negative square root of 3 over 2. Right, that's going to be, I believe, 5 pi over 6. So what I want here is the tangent of 5 pi over 6. And what's that? Well, maybe you remember it. Maybe you use the identity here. This is the sine 5 pi over 6 over cosine 5 pi over 6. To be perfectly honest with you, I don't have the tangents memorized. Usually if I need a tangent, this is how I do it. I just go to the sines and cosines and divide them. So this is going to be 1/2 divided by negative square root of 3 over 2, which is negative 1 over the square root of 3, which is negative square root of 3 over 3. And there's your answer. Again, it really is just being mindful of those range restrictions. All right, so how about this thing? All right, that's not one of our special numbers. I don't know an angle whose sine is negative 2/5. All right, well, here's how we do these. Right? First, remember, the inverse sine of a number is an angle, right? So this is saying, let's write it that way. Let's let theta equal the inverse sine of negative 2/5. Okay, well, look, take the sine of both sides. This means the sine of theta equals negative 2/5. Okay, good. That's something I can work with, right? So let's do this. I'm going to draw a right triangle. I'm going to put theta here. And I know that the sine of this angle is negative 2/5. Sine is opposite over hypotenuse. So I'm going to put a 2 here and a 5 here. Disregard the negative sign, all right? I'm going to think about ranges and quadrants and get the negative sign straightened out at the very end. All right, so what is this side here? All right, what is this missing side? Well, I can do the Pythagorean theorem to find that. X squared plus 2 squared equals 5 squared. That means x squared equals 25 minus 4. That's 21. So x is the square root of 21. Good. So this is the square root of 21. That means that the angle, the number that I'm looking for, this is the cosine of theta. But the cosine of theta, look at the diagram. It's adjacent over hypotenuse. So this is the square root of 21 over 5. Now all I have to do is I have to fix up I have to double check the sign, right? Because this is negative 2/5, theta must be a fourth quadrant angle. All right, well, in the fourth quadrant, the cosine is positive. So I need a positive number here, and that is my answer. Positive square root of 21/5. Now, I see some people, when they do this, they try to put a minus sign in the triangle, right? They try to make it either a -5 or a -2. that's a tricky business, right? Because if you would put the minus sign here on the 2, we'd have gotten the right answer. We'd have gotten a positive answer. If instead you would put it here on the 5, okay, then you would have gotten a -1 and your answer would have been wrong. So when I do these, I leave worrying about the minus signs until the very last minute when I can just think about which angle or which quadrant my angle is in. Okay, so give this one a try. Right, try this one out, see what you come up with. So I'm going to do the same approach. I'm going to let theta equal the inverse cosine of -2/3, which means the cosine of theta is -2/3. Okay, so let's draw a triangle, right? And I've got my angle theta here, and I know that the cosine of this angle is -2/3, which means the adjacent side is going to be 2, and the hypotenuse is going to be 3. All right, so what does that make this side? Like, again, Pythagorean theorem. X squared plus 2 squared equals 3 squared. So x squared, let's see, that's 9 minus 4, that's 5. So x is the square root of 5. And now I can answer my question, right? This is the tangent of my new angle theta. And looking at the diagram, the tangent is opposite over adjacent. So this is the square root of 5 over 2. And now let's think about quadrants. Theta has a negative cosine, which means it must be a second quadrant angle. And in the second quadrant, the tangents are negative. So that's it. There's my answer. Okay, so how about cosecant, secants, and cotangents, right? How about their inverses? Well, I can walk through the same arguments that I did with the sine and cosine and tangent, but I think you've got that down now. So I think it's easier if I just kind of fill out my table, right? And give you these ranges, because once again, it's the ranges that are important. I have the sine, cosine, and tangent here. Those are the ones we've already talked about, right? The range of the cosecant is, and remember, cosecant is 1 over sine, right? You notice the range of the cosecant and the range of the sine are the same, right? The secant is 1 over the cosine, and their ranges are the same. Okay, now, sorry, the tangent and the cotangent, yeah, okay, those are different. Sorry. The tangent we have here, that's the negative pi over 2 to pi over 2, just like we saw before. And the cotangent is going to be a little different. The cotangent is going to be from 0 to pi, right? And again, just like before, right, notice I did not include 0 and pi, right, because there is no number in the domain that's going to give me those angles, because the cotangent of those angles is undefined. Okay, so let's look at these new inverse functions, because students get into trouble here, right? They see these and they think, well, you know, look, secant is 1 over cosine, right? So maybe this is 1 over the inverse cosine of 2. All right, well, unfortunately, that's not the case. And you figure this out pretty quickly if you go to your calculator. 2 is outside of the domain of the inverse cosine function. Domain of the inverse cosine function goes from -1 to 1. So if you try to put that into your calculator, it's going to get a little upset with you. All right, so how do we do this? Well, look, here's how I'm going to do it. And I actually want to go for a formula here. So what I'm going to do is I'm going to say let the inverse secant of x equal theta. That's an angle. All right, so let's take the secant of both sides. If I do that, I get x equals the secant of theta. And secant of theta, that's 1 over the cosine, right? 1 over cosine theta. Now let's flip both sides over. 1 over x equals the cosine of theta. And now take the cosine of both sides. Theta equals the inverse cosine of 1 over x. And there's our formula, right? Because theta equals this and theta equals this. So those things are equal to each other. The inverse secant of x is the inverse cosine of 1 over x. And you get the same formula for the other pairs. The inverse cosecant of x is the inverse sine of 1 over x, and the same with the tangent and cotangent. Okay, so how do we answer our question? Well, let's jump back up here, right? And my formula says this is the inverse cosine of 1/2, and I know what that is, right? The inverse cosine of 1/2 is pi over 3. All right, so try this next one. Right? Try doing this with the cotangent. See what you come up with. All right, so let's see. My formula says this is the inverse tangent of -1 over the square root of 3. And now think about what this is saying. I need a negative angle, right? I need a fourth quadrant angle, a -1, whose tangent is -1 over the square root of 3. That's going to be negative pi over 6. All right, so this next one, now we really do need the formula. There's just no way around it. This is, let's see, cosecant goes with sine. So this is the inverse sine of 1 over -1.15, which my calculator says is -1.366 radians. Okay. We're not going to use those very often, but they will come up every once in a while, so I did want to make sure we talked about them. And now, at this point, we have all the tools we need. Now we can start talking about how to solve trigonometric equations.